All right, some of the enrichment questions just involve quadratics or factorizing first. So, for example, if we're solving between 0 and 360 here, a 4 sine cubed theta is 3 sine theta. What I do is just put everything on one side, and at the same time I'm going to factorize because they've both got a sine theta in them. All right, so this ends up being 4 sine squared theta minus 3. Sorry, I had to go over there. Okay, so that's the same equation factorized. Now, when you factorize, remember, you've got now two kind of brackets here. So either the first bracket has to be 0 if it's got to equal 0, or the second bracket's got to be 0. So either sine theta is going to equal 0, or 4 sine squared theta minus 3 is going to equal 0. Now, this is fairly easy. We know the sine graph. If I do it over here for a second, if you remember your sine graph between 0 and 360 is 0 at 0, 180 and 360. So we already know it could be, the angle could be 0, 180, 360. For that one to work, for this one to work, we could add 3 to that side and then divide by 4. And just remember, this is when we square root, we get plus or minus, and we square root, we get root 3 on 2. Now, this is between 0 and 360, and it's plus minus, so we're going to get 4 answers because we want all quadrants. So remember, we're going to have first of all, the theta quadrant. So sine 60 is root 3 on 2, so I know that's going to be 60 degrees. Then we've got the second quadrant, which is 180 minus 60. I'll just write it in. Then we've got 180 plus 60, which is 240. Then we've got 360 minus 60, minus theta, minus 60, which is 300. So if I put these two together, and which I should do, so therefore I usually say theta equals, and then I'm going to list them all, either the first 3 and then the first 4, or you could even try and put them in order if you can. 300, sorry about the messiness. And that, there you go. So they're all your answers. All right, so let's look at a different quadratic one. I can't even say it. No, I don't know how to do it. Okay, so if I go clear canvas, there we go. All right, so let's try this one. What if we had a mixture of, so in this case, we've got cos squared and we've got a sine theta. All right, again, we're solving between 0 and 360 for theta. So you can see it's quadratic, but there's coses and sines. And again, we want everything to be sine or everything to be cos or etc. So I know that if I remember rightly, sine squared theta plus cos squared theta equals 1. So identities come in really handy. So cos squared theta must be 1 minus sine squared. So if I change that to 1 minus sine squared theta, now everything is in terms of sine theta. So if I expand that out and also put the 3 on this side, or actually I might put everything on the other side because then I get a positive sine squared theta. So I've got 4 sine squared thetas. I've got negative 2 sine thetas. And 4 minus 3 is 1. I've got negative 1 here. All right. So if you think about it, really, it's a quadratic that is going like this, like so. That's what we're solving. So up to you how you do it. For example, you could say, I'm going to use the quadratic formula. So negative b plus minus square root b squared minus 4ac, so that's 16 on 2a's. All right, so we're going to get, so we're going to get 2 plus minus 16, 17, 18, 19, 20. 20 is 5 fours. Whoops. Alright, this is root 5. 5 fours over 8. So you are going to get, if I divide by 2, I'm going to get these two different answers here. So that's fine, we can do that. Remember, we've just solved for m there, so m is representing sine theta. So we're really saying sine theta equals 1 plus minus root 5 on 4. So remember, we are going between 0 and 360, so I do want the acute angle, but I also want 180 because this is negatives and positives here. Let's just, so if I do 1 plus root 5 and divided by 4, right, so that's going to give me 0.809 blah blah blah, and I'm just going to store that for a second. And if I do 1 minus root 5 and divide that by 4, I'm going to get negative 0.309 something. So if I just store that as well, I've got those two there. So I'm getting positive and negative answers here. So we know we want to use all quadrants. So I'll just add that and that quadrant. There we go. So if I start with where theta is positive, where sine theta is positive, I want this one and this one. So if I do inverse sine of that, inverse sine of I put it under A, I think. Oh, right, I get a 54 degrees. So I can see that I'm going to have 54 degrees and 180 minus 54 degrees. For my negative, if I think about where sine theta is negative, I now want these two. All right, so 360 minus theta and 180 plus theta. But what is theta? All right, I need to do inverse sine of the negative 0.3 stuff, which I put under B, and we get an 18 degrees. All right, so let's just check that. If I did 360 minus 18, I get 342 degrees. 342 degrees. If I do, oh no, I've just forgotten what I was doing, so shift sign of my B was 18. All right, so 180 plus 18 is 198. 198. Which is in that quadrant, so just checking. So I'm going to have 4 answers. That's 126, that's 342, and that's 198. Alright, I probably should have written it separately so it would have been easier to see, but really we're solving the plus case first, so we got these 2 answers. Then we're solving the negative case, so we get these 2 answers. It can look a bit tricky, but give it a try.